to today's program of ARA Webinar Wednesdays. I'm Jerry DiMaggio. I'm usually, and today included, serving as your host and moderator for today's program. I'll begin by covering some housekeeping items, introduce today's presenter, and then I'll return to the conclusion of the technical program to address and facilitate the question and answer program. I would also mention that this is an emerging area of highway transportation related to safety, as Eddie will get into. So please stay attentive. I think you'll thoroughly enjoy today's program. A few housekeeping items first, though. Next slide, please. So if you're having some problem listening to the program and you're calling in with your computer speakers, please shut them off and try calling in with your cell phone. If that doesn't work, then as you can see highlighted in this slide, go to the chat box, send a message to the host and the host only, and we'll try our very best to help you with resolving your problem. Next slide, please. We encourage you to ask questions throughout the program. We'll defer addressing the questions until the conclusion of the technical session, and we generally permit about 10 to 15 minutes to address Q&A. If we do receive an excess of questions, our speakers will be interacting with you after the program. We'll talk more about that at the conclusion of the technical program. Next slide, please. Finally, if you're having a problem in terms of viewing the presentation, go to the top of your screen again, click on the down arrow, highlight view, and then as shown in this slide, emphasize or highlight fit in as a viewer. So it will fully populate your screen, hopefully at that point. It shouldn't be a problem. Next slide, please. Now it's my great pleasure to introduce my good friend, Dr. Edward Ofe. And Edward originally got his doctoral degree in Ghana, as you can see. He's got his MS and his PhD from the University of Wyoming. He's been with ARA for a while. He started his career working as a project engineer in Ghana, as you can see here. His specialty areas are in the non-destructive testing arena, pavement evaluation, pavement design, structural analysis and research, and he's also focused on construction quality assurance and supervision. He's been, for quite some time since joining ARA, one of our in-place staff and task managers at Florida DOT in Gainesville, and he'll be sharing some of that work with you today. Eddie, I'd like you to take the program over.
Okay, thank you so much, Jerry, for the excellent introduction. And good afternoon, everybody. I'm very pleased that you've decided to join this webinar. This webinar will talk about Florida statewide pavement marking data collection and management system, as Jerry mentioned. And for the outline, I'm going to go through all of this. I'll talk about the historical background of Florida DOT pavement marking program. Also talk about, pavement marking retroreflectivity, the data collection, data quality assurance, which is very unique to Florida's program, and also their management system and the reporting, and then the reporting as well. Before I begin the presentation, I would like to acknowledge these people at the Florida State Materials Office, Dr. Buzi Chuben and Mr. Charles Osher, for their vision and leadership for this pavement marking program that they worked so hard to establish years ago. I would also like to acknowledge all who have contributed in diverse ways to the success of this program, especially the MRU team and the guys who goes around collecting data statewide in Florida. So a brief historical background. As you can see, in early 2002, the department started a customer survey of the public to get some feedback on their network. And what they got with all the other feedback and all of that, elderly drivers were concerned with guidance of roadway markings, meaning the conditions of roadway markings were not that good. And as you may all know, Florida have a lot of elderly population. So those elderly drivers were very much concerned with the roadway markings. So following that, in 2004, the department purchased MRU, which is a mobile retro reflectivity unit, as you can see right here. And since then, they've been refining the capabilities. In 2009, the department built a calibration bay so that they can do data quality assurance or quality assurance testing of the unit in the bay. In 2012, they developed a pavement marking management database. So this database houses all the data that has been collected since 2014. And in 2014, they started a statewide contract, and ARA has been part of this data collection or statewide contract since 2016. So what is retroreflectivity? Retroreflectivity is created when vehicle headlamps, as you can see, are redirected back to the operator or the driver. So the headlight shines onto the marking, which is here, is right here, and the beads reflects back the retroreflected light back to the driver. And most materials utilize glass beads to create that reflectivity that we're talking about. As you can see on this side, this is a daytime, you can see the beads, and then the nighttime, you see how the beads is giving enough retroreflectivity. So the level of reflectivity significantly impacts nighttime visibility, and it's important to keep your the system, especially the pavement marking, at a very high level of retroreflectivity. So just a question. How do you think these traffic signs, as you see right there, and the markings on the roadway will perform at night? I mean, we can see the traffic signs and some of the markings. As you can see, the skip lines are a little bit, faded. But what will happen at night with these conditions? So let's see what happens. So at night, what you see, we cannot even see the pavement marking, meaning there's no retroreflectivity, and this is very dangerous. So this is unsafe. And I don't really think any road agency will want their system to perform this way, because this is actually a disaster, waiting to happen. So that is why it is important to have a level of retroreflectivity that will be good for nighttime visibility. So moving on, Florida, as you may all know, is third populous state in the country after California and Texas. We have a lot of millions of annual visitors who come in for, to visit some of the sightseeing in Florida. So that means on our network, there will be a lot of traffic. So meaning that we need to have our markings should have a high level of retroreflectivity that can guide drivers as they drive year-round on our roadways. And also, Florida have a higher, elderly population, 65 years and above, almost 21%. And the reason why it is important to keep these striping visible is that as you age, your need for light doubles every 13 years. So you look at this chart right here, if you are age 46, you need 4 times more than somebody who is age 33. And as you go forward, it increases doubles. So it's very, very important that the markings or the visibility of the markings is at its topmost level. Also, as you age, your response time is slower. So assuming the previous slide that I showed that, the marking is even non-existent at night, that's not what you want. You want markings that are visible. So that's why it's important to have higher retroreflectivity values on your network. So the FHWA have come up with some guidelines to maintain minimum retroreflectivity for pavement markings. And in their guidelines, they stated that for a standard, the minimum that we could go is 50 millicandelas per meter squared per lax. For roadways with posted speed limit 35 miles per hour or greater. And for their guidance, they specify 100 for higher speed roadway, as you can see. So based on this, the Florida DOT came up with their own classification of good, fair, and poor, as you can see on the left corner right here. So what is the good? The good is that when you have a retroreflectivity value of your marking greater than 250 millicandelas per meter squared per lux, it is termed as good. And the fair is when you have retro values between 150 and 250, and then for poor is anything below 150. So although the guidance from the FAW is 150, we have sort of raised it high, and the reason is just to make sure that your system is performing at utmost benefit to the public, more especially to the elderly population in the state. So some of the traditional restriping strategies that we've done in the past, as you may all know, windshield survey has been with us for years. And this is where somebody sits in the vehicle and then just look at a stripe and say, okay, this is good, this is bad, this passes, or this. And this is subjective because it depends on the person doing the survey, the quality of the eye or the age of the operator. Also, we've also done handheld retroreflectivity where it is site specific. As you can see in this picture, this is the retroreflectivity handheld unit, and they are taking measurements on this skip line. But then you need MOT, you need a track attenuator to protect these operators. So this is what we've done in the past. Also, we also do predictive methods. Most of the road agencies just have a definite cycle or restriping cycle, maybe 2 to 3 years. But the negative part of it is that your network may not be all deficient within that 2 to 3 years. So it's not very efficient in a way of using maintenance money. Also, performance contracts where AM contractors will be awarded contract to look to maintain a network or a system. So with that, they will maintain it for as long as it is good, but then at the end of the contract, what happens? So some of the objectives that the DOT set for itself, and the main mission of the Florida DOT is to ensure safe transportation system for the public. So in so doing, we need a system, and that system that we need is a Pavement Marking Management System. So that management system is going to monitor the long-term performance of the retroreflectivity on the roadways in Florida. And also that system is going to support maintenance. So we get data, inventory data on the markings. It's going to support maintenance, also safety. For safety evaluations, they're going to use the inventory data on the markings, also design initiatives. Above all, whatever data that is collected will be used to give data-driven decisions. So some of the goals of the PMM program is that it's going to be a statewide, or it is a statewide evaluation where we do data collection on a network level. We do have a pavement management system database. Also, we assist in safety investigation. We also assist in environmental experimental projects, So the experimental projects, we look at new materials. So if there are new materials that a district wants to evaluate, we go in there and then assist them. Also construction methods. We're using this program to assist all of that. Also, one of the goals is to continue to maintain a high-speed data collection equipment, which is efficient means of data collection. And also, above all, our goal is to improve the safety of the traveling public and as well as the field personnel. So this high-speed technology, as you can see, it is a track mounted. So this is a laser log generation 7 that we are using currently, and it's mounted on a track, as you can see here. It follows the same method as the handheld, but the only thing is that this is on a mobile platform. It's attached to a vehicle, and it is a high speed with a laser. It's a laser-based system which emits about 400 scans per second as it travels on the roadway, and the testing speed can be up to 70 miles per hour. And the data is continuous, unlike the handheld retroreflectivity unit. And also there's no maintenance of traffic required to do the testing. And this measurement follows the 30-meter geometry. We're using a 1 feet scale of it. And that is what happens on the field. So as you drive on the field, as you can see the animation, the laser goes onto the roadway, measures the striping and goes back and measures and then stores the information. There is onboard laptop that measures, that stores the data as the driver drives on the roadway. So this is the data acquisition software. So as the data is being collected, the operator in the vehicle can see the condition of the striping shown by the number and also the scale. As you can see, 206, retroreflectivity of 206, and so on and so forth. So our pavement marking management program, which DOT has, is a full-time year-round. So meaning that we do inventory every year, so back to back. So we finish a cycle, we continue right the next day after a cycle is completed, we continue another cycle. And our task is for us to collect about 25,000 lane miles of markings per year throughout the state of Florida. And out of that, the breakdown is that we have to do 12,100 lane miles of yellow center lines, and then also 5,300 lane miles of white skip line, and then 4,500 of edge line. And then the rest is reserved for special requests. So maybe for research, for safety, or district needs. The district have a need that they want us to verify a certain section on their system. They may call up to us. So we do those up to about 3,100 lane miles. So our staff that we have, like I mentioned, as ARA has been supportive of this program for the Department of Florida, for the DOT, since 2016. So we have 3 staff, a data specialist, and then we have two field technicians. One unique thing about Florida's program is that they also have a quality assurance team, which is a consultant independent from the data collection consultant. They are different consultants. And what they do is that they verify whatever data collection inventory is done by the contractor, meaning the data collection consultant. And they also have 2 teams, a QA specialist who looks at the data, and then also a field technician as well. So this program is managed by a program manager from the DOT. So all these staff are consultants. This is a DOT personnel that manages the program. So regarding data collection, like I mentioned, we're supposed to do 25,000 lane miles every year. So our cycle year starts April 1st of, let's say, 2021, and then ends the following year, March 31st of 2022. So that's what our cycle year is. And once we are done on March 31st for that survey year, the next cycle starts the next day. So that's how busy it is, and this has been going on for years. So typically, we review the list of roadways to be tested. So the 25,000 lane miles, we receive that from the department, and then we have to review it as the data collection consultant. We review that to make sure everything is right, and we also start our route planning based on the information on the list of roadways that we need to test. The good thing is that we have an in-house developed map view, as you can see at the bottom, and a navigation tool that really helps us to plan our route for the year. So that's what we do. And this is a sample of the data that we get, and this sample, this data output sample is conforming to DOT's worksheets that they've designed. I'm going to talk about that later. But then as part of the data collection, we also output KML file. So this KML file, everything is loaded electronically to the DOT database. As you can see, the KML, this is a section that was tested, and it's all green and yellow. So what does it mean? So the green color coding means that the retro values are higher than 250 millicandelas per meter squared per laps, and anything in the yellow, the yellow color coding, it's retro values between 150 and 250. So you can see, as an agency, you can see that this section is really good. I mean, it's between the good and fair. We don't really have any poor sections. So this KML gives us a visual view of the data collected. So for every program, you need to have documentation, and Florida DOT have been very, very good from the onset to have all these things in place. So what you guys are looking at right now is the Florida test method, and this was developed as part of the program. And what this does is that it specifies how to measure retroreflectivity of pavement markings using the mobile retroreflectivity unit, MRU. And this is available to the public. So if you're a contractor that you want to do testing, let's say pavement marking on any roadway in Florida, you need to meet everything spelled out in this test method. So the test method, specifies the equipment that you have to use, the terminology or the nomenclature of the markings that you are testing. So the nomenclature is what is right here. So if we take this particular roadway, it's a 2-lane two-lane roadway with a double yellow divided center line, with a double yellow center line. Going up or north direction is termed as up station, and going down is down station. So that the nomenclature is R. And when you are testing this edge line, this white edge line, it is called EL. So REL meaning you are testing this edge line going up station. And then the reverse is the same for the southbound or the down station. So all this you need to conform to that. And also this same test method talks about the calibration and the standards, the operation procedure, and even the reporting formats that your output data should be in, and also the precision requirements. I'll talk about some of these as we go along. So the standardized data worksheet that I just talked about. So the Florida DOT have this worksheet, which is standard. And the reason is every contractor needs to have their data outputted in these formats so that we can be able to upload it to the database. So with the MRU operations, there's also a manual that will guide you the do's and don'ts. So equipment mounting, calibration procedure, setting up a testing with MRU, data processing, monthly maintenance, and even troubleshooting. So we've captured all of this in this document, which is available. The latest update was March 2020. So we keep all this documentation so that the program will be good, so that we have repeatable data, so that we have data that is repeatable. We want everything to be documented so that we do the same thing over and over again. In addition, the department, like I mentioned in the historical background, the department established a calibration bay and testing facility. So this is how the calibration looks like. As you can see, we have a vehicle mounted laser logs, and we are verifying this stripe in the lab, that meaning a uniform condition or a controlled environment. And this striping has a known value. So usually we bring in most of our equipment in here, or all the units that we have, and then we verify the machine. So if the machine reads closer, then it means we are good. Also, the calibration facility, we do a lot of research as well. Quality assurance of the FDOT program. This is the biggest piece of the program that the DOT has. So with this quality assurance, it really spells out everything that needs to be done in terms of quality assurance of the units. So the unit is the the laser logs that you have. So contractors' units and even DOT's own unit. DOT have 3 units, and we as AR we also have 2 units. All those units have to pass through this quality assurance test. And so some of it are the equipment inspection, calibration procedure, equipment sensitivity, operator competency. And I'll come back to all of this, and field verification and data validation. So as you can see, there are 2 types of testing. There's a laboratory piece of it, and there's a field testing piece of it. And these are done at different testing frequencies. So the contractor's unit goes through this quality assurance process, same as the DOT's, FDOT's unit. So with the laboratory testing, the setup, and then the visual inspection in the calibration that I showed in the previous slides, we have this fixed stand, which is vertically aligned with this flat table right here. And as you can see, the distance between them is 6 feet, which is similar to what, when it's mounted on when the unit is mounted on the truck, the laser shoots at that distance. And we also have a vertical adjustment here to compensate for stripe thickness when we put it on the table. The laser, usually we direct the laser onto the table, which pretty much mimics the ground. And the profile that is generated, which is a close shot right here, we measure it to verify its shape and then size. As you can see, the laser profile should be parabolic, and this is about almost close to 39 inches. So verification testing. And this is part of the quality assurance program that the Florida department has as part of their PMM program. We have 12 standards. So the 12 standards that we have, it includes panels, longitudinal panels, as you can see, and then these 2 vinyls, and then ceramics. So we have 9 longitudinal panels of different colors, and all these are beaded with the beats. We've put beats on it, and the values, the RF values are known. So how do we obtain the RF values on these panels and these, vinyls and ceramic? We take it through photometric range. So we have the department have a photometric range at the State Materials Office here in Gainesville. So where we take the panels and we measure, and this is the industry standard. This is a gynometer. So we measure the panels. And once we measure the panels, we don't even assign the number right away. We do a 6-month moving average. So we go there every 2 months. And then at the 6th month, we do the moving average of those 3 set of data that we have, and then we assign it on the panel. So then it becomes a standard of each panel. So that panel goes back to the calibration bay where we check each unit. So for instance, this panel have a known assigned value that was obtained from the photometric range. So the one unit will measure it. So a known value, and once a unit measures it, it should be within, the criteria should be within 15%. If it goes beyond 50%, it means that the unit has failed the laboratory verification. So what happens? It means I have to redo that again, or we have to send it to the manufacturer, meaning the MRU unit to the manufacturer. We also check background noise testing in the lab. So this is very important to ensure that the retroreflectivity readings are not influenced by background noise. So what are the background noise that we use, or the types of backgrounds that we use? We use RPM. So as you can see, this is a longitudinal striping here, and we've introduced the RPM, meaning a race pavement marker here as a background to see whether it's going to affect the measurement here. Also, we use a ceramic right here, as you can see, to see whether it was going to affect, and also a white and a black background. So what it means is that this background is simulated in the lab and on the table that I showed in the lab. That's where we do all of this measurement. At the end of the day, the criteria is that the readings that are measured on this with the interferences or with the background, the 3 different backgrounds, should be within 5% of the standard laboratory value of this longitudinal stripe without any of these interferences. So this is pretty cool, and that's what every unit. So if you're doing, before you do any data collection for the Florida DOT, your unit have to go through this rigorous data quality assurance testing in the lab. Also, we do a dynamics testing, equipment dynamics testing. This is to ensure that the readings are consistent even during lateral wander. As we drive, we tend to wander a little bit, and it's natural. So we mimic this in the lab and then try to measure that and see whether even if we move from one side to the other, the values will still, or the retro values will still be consistent. So as you can see, we start from the center. So we start from the center, we put a panel in the center and we measure it. And that is the ideal situation. Although there's a profile, you want the highest measurement to be in the center. So we measure that. And then we move this panel to the right and left at 5 inches increments. So we move it to the left 5 inches from the center. Then it goes the next 5 inches, that will be 10, 15, and so on and so forth. So once we do that, the criteria is that we average the 3 center readings that we obtain here and compare it with the movement on either side. And also the criteria is that it has to be 10% of the average of the 3 center position reading. So this is what we do in the lab to simulate lateral wander. And like I said, all the units that do data collection needs to pass this test. Also, we do DMI and GPS accuracy. And we have a dedicated site, a measured mile site near the State Materials Office in Florida. This is where all contractors or FDOT testing equipment have to go to calibrate or verify their DMI. So before you do any data collection, you go through a lot of all these quality assurance processes. You have to do that so that at least the DMI is within the tolerance that we said it is. So for a GPS-based DMI, the criteria is that it should be 10 feet, plus or minus 10 feet, the DMI distance. And also for a mechanical DMI, the criteria should be 0.1%. And this section is a 1 mile from this arrow. As you can see, we've done a lot of dots and measurements on this roadway. So it starts right here going 1 mile that way. Also, as part of the quality assurance program, we also do precision testing. So the precision testing is to ensure repeatable and reproducible measurements between different MRUs. So what we do is that we have 5 sites very close to State Materials Office. So these 5 sites have different pavement types, and also we test different striping, skip line, we test the edge line, so on and so forth. And at each site, we do three repeat runs. So 3 repeat runs for a mile long, and all the 5 sections, the area values are pooled. So once they are pooled, the results from the contractor's data should not differ by more than 10% for repeatability and 15% for reproducibility when compared to FDOT's reference data. So if a contractor fails that, he has to redo the precision again. So you continue to do this precision test until you pass it. Sometimes there may be an issue with maybe something with the equipment. So sometimes after 3 precision tests, we take it to the lab and then go through everything I've mentioned or I've talked about. We go through everything again just to make sure that there's nothing missed during the lab part of the test. Also, we also look at stability, and we look at two items. We look at speed. We look at testing. We look at testing during the we look at testing at different speeds, 35 and 55 miles per hour. Also, we look at different test temperature. So, like for instance, usually for the temperature, we test it in, and then we test in the afternoon, just for those 2 different temperatures. And for all of these 2 test procedure for stability, the criteria is that we should be within 10% of the results of the 2 different results. So operator competency. So as part of a contractor being certified to do data collection, the operator or who the technician is have to go through a competency test. So this competency test, there are 5 sites that have been earmarked by the Florida Department very close to the office, where the operator have to navigate that roadway with the MRU mounted, as you can see here. So the factors that we evaluate are that we look at whether the operator can use event codes properly. So what are some of the event codes that we look out for? We look out for bridges. So when you're driving and testing this and there's a bridge, you get to a bridge, you need to event it and let us know that there's a bridge. Even if there's a pavement change, you need to show that there's a pavement change ahead of you, and so on and so forth. We also look at whether the driver can drive competently without wandering unnecessarily, and also look at whether the driver can also effectively plan its route or the 5 test sites that it needs to test as part of the competency test. Also, we also look at whether the driver or the operator can be able to properly use the FDOT striping nomenclature. And so all these factors will be used to evaluate whether the driver is competent or the operator is competent to operate the MRU to collect data on behalf of the department. So the criteria is that the results obtained from the contractor is compared to a DOT data. And this is spelled out in the project level quality assurance document, the document that I showed earlier. Everything is captured in there, but then it's compared with the DOT like standard data that they've already collected. Is compared to that. And if the operator meets all of the factors mentioned here or outlined here, then the operator is good to go. And you are good to go for 2 years. So every 2 years you need to recertify, and you have to go through that over and over again. And this is done to ensure that we get the highest quality data. And I think it's a very, very good part of the program as well. So data acceptance. So once you've gone through the data, the operator competency, you've been certified to collect data. What happens when, as a contractor, you collect data? What happens? So the Florida DOT, as part of the quality assurance document, they will verify 20% of the statewide data that the contractor has surveyed. So in this case, ARA is doing 25,000 or is collecting 25,000 pavement marking data on behalf of the department. So the DOT, using their quality assurance consultant, they will sample, and this is random sampling, 20% random sampling of the 25,000 that we've collected, and then they will compare. So if they compare and the comparison differ by 75 RL. So this is a simple tool. We use a template right here, and then the graph right there explains much better. So the black line, as you can see, is FDOT data that was collected on the same roadway with this roadway designation, and the green is the contractor data. So this is very, very, very close. You can see there's even no difference in terms of area difference, significant difference between the two. So we check all of this, and then this tool helps us to be able to identify the section. So with this, it says there's no section that was flagged, 0. But if assuming that this data doesn't agree by more than 75 plus or minus 75 RL, the contractor is requested to rerun the section that failed. So if this roadway, like for instance, this is a 22-mile roadway, if the contractor failed at more than 30% of this roadway, he has to rerun the entire 22 miles. It's not just the section that failed. And that is criteria 1 for comparison. The second criteria is this, which is the bottom one. So for a week, and this comparison or data acceptance is done week by week. So a contractor goes out to test maybe Monday to Thursday, comes back with the data, DOT samples 20% of that, goes out and then verify that. So let's say a contractor tests about 100,000 lane miles a week. 20% is sampled by the department for verification. So out of that 20%, if more than 30% of that 20% differ by more than 95 RF value, the entire week of data is rejected by the contractor, is rejected by the department, and the contractor must resurvey all the 1,000 lane miles for the week. And so far, that area has been doing this. We've always passed this. Yeah, we may fail one of these due to this criteria, but we've never been in this zone. So that's a very good thing. And this is showing in the next slide. So the next slide is showing the rerun trends. So the roadways that were flagged for the contractor to rerun. And what you are looking at is a 4-year data. So since 2017, and this is out of the 25,000 lane miles that we've collected. So I mean, 1,400 is good, but then we said, no, we need to improve. So over the last 4 years, we've tremendously reduced our rerun or the sections that were flagged for us to rerun. So that is very good, and we're still working on fine-tuning it. And I think the biggest part of it is the quality assurance program that the department has to check the equipment to make sure all the equipment, performance are within tolerance that the document says. So I think this is a very good thing for the program. So moving on, so I'm going to talk about the pavement management system database that the department has established. It is a web-based database, and the features that it has is that it's got a query tool. I'm going to show it right there. So it's got a query tool. So you can query by the district, county, and all of this. You can query by all of these features. It also has a GIS mapping, a video log, graphs, and then tables. I'm going to show all of this as we move along. And also, it is on a mobile platform. You can just install it, use that link that I showed in the previous slide at the bottom. It's on your mobile phone, and then bingo, you can have access to it. And it's open to everybody, not just FDOT employees or contractors. It's open to everybody. So people on this webinar call can get access to it. Even people from other states, and look at what Florida DOT is doing. Also, some of the query filters. So you can query a particular roadway and then look at the tenth. So we have a tenth. We report our results in tenths of a mile, as you can see. So what you are looking at is that you're looking at LCL. That's a center line, a yellow center line going down station, and then a skip line going up station. So anywhere that you see red, that tells you that a retroreflectivity value is below 150. If you people will recall, I mentioned about the classification, the 3 classification, good, fair, and bad. So anything below 150, the RF values below 150, we code it as red, and that's what you can see over there. The yellow is RF values between 150 and 250. And also the ones that have not been color coded are RF values above 250 millicandelas per meter square per law. So meaning they are very good. So when these results, maybe as an agency or maybe a maintenance section within a district in the state of Florida, you look at this and your system is not looking too good, you can look at this and maintain, say, okay, I need to maintain this side. Instead of restriping everything, I have to maintain the ones that are in the red. Also, we can report the data in a graphical form. So on the vertical axis shows the retroreflectivity values, and then on the horizontal shows the distance. And we can report it in the graph or table format. Also, we have GIS mapping. So the GIS mapping, as you can see, you can query by a roadway, or you can zoom out like this and look at an entire county. So what you are looking at is that all these are counties. All these are counties. So the counties with green color coding, what it means is that within that county, you have a lot of roadways that have very high retro numbers. It doesn't mean that you don't have roadways that are failing. What it means is that you have more roadways that have higher retro numbers, and we're looking at the county average, pooled average, and that's why it gives you that. And I think this is good, and you can drill down as a maintenance office, or safety or whatever you want to use the data. You can drill down and look at those roadways that have issues. And right here in this county, it's telling you the county average is in the red, meaning the retro values are less than 150. But there will be some roadways that are good, but just that the majority of roadways are very low or have very poor rating in terms of classification. Also, like I mentioned, you can just look at your county and then drill down. This county has yellow markings, yellow color coding, and then green color coding. The meaning is very good. I mean, the striping is good within that county. Also, we have a video log. So what a video log does is that it gives you a visual of the section of the striping. So you look at numbers, you're like, okay, what does it mean? But then you look at a video log, you can tell, okay, this looks good. And this video log is within the application. So that's it right there. So you click on it and it's going to open that video log right here. So in terms of reporting, once we collect all the data statewide in a year, what do? We do a reporting format, and this is an example of it. So we look at the different system, and then also look at the different stripe system, the striping that was measured. So center, skip, and then edge. So the yellow is center line, yellow center line, and then this orange is a skip line, and then the green is edge line. So we look at it based on each system. And this is an example. So this is looking very, very good. I mean, most of the numbers are above 200 and above. So that is very good based on FDOT's classification. Also, we look at deficiency reporting, percent deficiency over time. And this is an example too. This is not real data, it's just an example. So what you want to see, you want to see a downward trend like this. So as an agency, if you start to see an upward trend, that's where you need to do further investigations to see what is wrong with your system in terms of pavement marking. So we capture all of this based on the data that we collect year to year. So anyway, I mean, I've talked a lot about the PMMS. So what are some of the benefits? The main benefit of it is to enhance the safety of the traveling public with improved nighttime visibility of the markings. Also, it helps us, the PMMS helps us to identify restripe locations. Like I showed the table results where you see a red and yellow. So as an agency, you can look at the red, meaning very poor sections, and then restripe those sections instead of just going about and restriping the entire network. So that's the benefit of the PMMS. Also, the PMMS data can be correlated to hotspot accident zones. So maybe you have your accident zones within the state. You can use the PMM data to see whether pavement marking is a factor in the accidents within those zones. Also, the PMMS can be used to facilitate the development of performance-based specification related to pavement marking. And it's all because you are getting this inventory year by year. So you can be able to develop a performance-based specification based on that. So moving forward, so where do we go from here? Where do the Florida DOT Pavement Marking Management Program go from here? We plan to continue to create awareness of the program to other states, to other road agencies, even to the public, so that they know we have something. Like I mentioned, the database is available to everybody. You can look at it and look at a section of a roadway within your neighborhood and see, okay, do we have very good, pavement marking? So that's what we want to do, is to create awareness through webinars such as this, or sport presentations. And number two, the second one is very key that we are going to work on moving forward, is to track new construction and maintenance striping, and then incorporate that into the PMMS database. Currently, we don't have that, but that's what we are working on moving forward. Also, the third one is that we are working to implement network level race pavement assessment. Currently, we don't measure RPMs, but there's a research going on which we are very close. We were looking at implementing RPM measurements in addition to the longitudinal striping. So these are the three things that we are looking forward to working on. With that, I would like to thank everybody for the attention and for listening. If you have any questions, I'll be glad to answer.
Thank you, Eddie. We'll get to the Q&A in a minute, and this would be great if you continue to ask questions. We do have a number of questions we'll get to. But before we do that, I'd like to remind everybody to look at ARA.com webinars for registration of some of our more up-and-coming, more recent, not recent, but future webinars through the August and October timeframe. We try to provide a diverse range of topics, as you can see here, mitigating explosive threats at United States airports. I would also like to remind all of our listeners that all of our speakers, including myself as moderator, are all ARA employees. On September 22nd, and we always bias our webinar Wednesdays towards the latter part of the month based on availability of the presenters, we're going to change gears from the hard side of the business, as I refer to it, to the soft side, improving human driver performance with feedback. And then in October, right before Halloween, those of you who practice that holiday, you'll enjoy that. I'll be shifting my role from moderator to presenter, and I'll be addressing risk management for infrastructure features that are related to geotechnical items, structural foundations, earth retaining structures, and engineered earthworks. So with that, we'd like to go to the next slide, please, to the Q&A program. Thank you, Eddie. So Eddie will answer as many questions as the time is available. And if he doesn't, and we receive more questions, and we have a number of them right now that we'll address, he'd be happy to communicate with you on the particular subject matter of today's webinar at his ARA email address. So Eddie, the first question that we have is from Greg. And Greg is curious to know, what conditions can you collect data on? Day, evening, rain, snow. Obviously not much snow in Florida, but could you address that, please?
Okay, thank you so much, Jerry, and thank you, Greg, for the question. So we can collect with our system, we can collect data during the day or night. But then, snow, like Jerry said, no, we don't have snow in Florida. But, wet condition, we try to avoid wet conditions because you're using a laser-based system. And if it's wet, you are not really measuring the condition of the striping. It's going to be refracted. The laser is going to be reflected. So we try to not to, do the testing when it is wet or it's raining. So that's, I hope I've answered that question. Great.
Yeah, I think you did, Eddie. So a couple more. One from David, and his question, and I believe you partially answered this, but you might want to elaborate on it. Is Florida DOT using this data for acceptance of pavement striping?
The answer is no. As of right now, we are not. All that we are doing is that we are using it for inventory purposes. Maybe in the future they may, but as of right now, we are not.
Right. And that's a very good question, actually, if you think about it. I have to say I'm personally amazed at the level of sophistication on something that even the professionals in transportation would not be giving that much consideration to. So Florida and yourself, kudos to you for kind of reaching out to being an emerging state or a lead agency in this regard. So next question is from Mary. And Mary would like to know if you could address how soon will Florida implement the Raised Pavement Markings RPM project?
Thank you, Mary, for that question. Like I mentioned, we currently we're working on a research. We are further along in that research. We're currently doing field data collection to verify the accuracy of the RPMs. And as to what timeline, I want to be very optimistic that maybe next cycle. So a next cycle, for the Florida data collection for the PMM starts, April 1st. So sometime next year by now we should.
Okay. So continuing on with the questions, and we're good from a time point of view. So if those of you who are still thinking about your questions, please send them in. So the third question is from Michael, and Michael would like to know, how is Florida DOT using the information of using this data for managing their overall program?
Okay, thank you, Jerry and Michael, for the question. So, like I said, we're doing inventory year to year. So, our biggest customer, and I'll say biggest customer because we work with them closely. We are supporting the maintenance initiative as well as safety and then design. So, primarily, the data that we collect year to year, the district maintenance offices takes those data for each district and then look at their system. So as I showed in one of the slides where I showed a tenth of a mile, and then you look at the data, some are red, some are yellow. So that's how the district maintenance office or the district is using the data. They look at that and say, okay, this particular roadway, the entire section it's not deteriorated as we think. It's just some few spots here and there. So that helps them to optimize their restriping contracts instead of restriping blindly restriping an entire section. Also, like I mentioned, Florida is using this data for safety related investigations. So for instance, I recall a year ago there was an incident in Miami where we were called upon, and I think it's on an off ramp where we were called upon to measure the pavement marking to see whether the striping condition, especially the nighttime visibility of the striping, was a contributing factor to the accident or incident. So overall, the department, and I would say the department or the other offices within the department are using this data effectively.
Okay, yeah, that's quite interesting because obviously a significant investment. Well, it'd be curious for agencies that haven't really had the degree of focus on this topic to kind of know about value-added return on investment relative to kind of convincing upper management to support similar programs. So we have one other question that's listed here, and this one is from Susan, and it's a very good question. What is the service life of pavement striping in Florida?
Oh, thank you, Jerry, and thank you, Susan, for the question. So, there are different types of pavement material or marking material. So this is a very broad question, but I will definitely, divide it into the different striping material. So if you take, for instance, thermoplastic pavement marking material, it's supposed to last about 5 years. But then the question is, does it, last that long? It depends on the region. So just a week ago, I talked to one of the maintenance office in Brevard County. So Brevard County, people who are familiar with Florida, is around the Melbourne area where the NASA, Air Force staff is. It's closer to the sea. So what they were telling me was that for most of their thermoplastic pavement marking material, it's not lasting as it's supposed to, the 5 years, but they're getting about 2 to 3 years out of it because of the ocean, and then the sea effect. So that's something, so once we talked about it, I'm like, okay, that's something that we need to look into it. So that's pretty much like a research focus right now. I've been thinking about it since last week. And also, like I mentioned, we have different types of pavement marking material. We have paint, and a lot of other states use paint. Florida also use paint in some other areas. And the paint lasts, or the service life is about 2 to 3 years.
Okay, thank you, Eddie. I've got one more question. In fact, we've just got time for this last question. This is from Fahad, and he'd like to know, are there any new pavement paints or types of markings that are better suited for autonomous connected vehicles?
Very, very good question. And I know there's a research going on at the federal level of contrast pavement marking. And I think for autonomous vehicle, you want that contrast between the marking and the subscript, meaning the pavement is whether it's concrete or asphalt. And so currently there is a research going on at the federal level. Regarding Florida, I've not heard that there may be some sections that they are putting some, but I'm not aware. But I think that the future is bright, especially with this area of pavement marking. So what it means is that we are sort of excited for the future of autonomous vehicle, because the markings are what they're going to use. And like I said, this contrast marking research going on will be good to also help with that.
Okay, thank you, Eddie. So that's the last question we have, and we're almost out of time for Q&A for today. If you do think of questions at the conclusion of the program or afterwards, you can reach out to Eddie by email. You see his email address in this slide for the next 24 hours for additional information. Please form your question as a general question. Don't make it a consultant question, and everybody should know what I mean by that. We'll do our very best, and Eddie is very effervescent and very knowledgeable in this area, so I'm sure he'll be able to help you. Next slide, please. Okay, so often asked questions is, what about my professional development certificate, and what about a copy of the presentation? So first of all, on behalf of ARA and Eddie, I want to thank you all for joining us today. Today's presentation is recorded, as all of our webinar Wednesdays are recorded. There'll be a link that'll be made available approximately early next week at the ARA Webinar Wednesday website. Also, if you've joined for the entire 1-hour presentation today, you're entitled to receive a PDH certificate. We'll be sending that to all the participants. Remember, you have to be on for the full hour. That's a requirement of the professional engineering associations around the country. Also, a copy of today's presentation in PDF form will be included, and just allow us a couple of weeks to receive your certificate and make that information available. And our final slide, please, Eddie. ARA is a national company. We do a lot of exciting things, as you can tell from the topics past, present, and future. And we're always looking for great people to join our team. We're at about 1,530, 40 or so at the moment. One of our mottos is engineering and science for fun and profit. It's a great company to work for. So if you're interested in current employment opportunities with ARA and our transportation and our infrastructure offices specifically, please send a brief resume and contact information to www.joinara@ara.com. I want to thank you again for joining today's program, and we hope you'll join us again on August 25th. Thank you again, Eddie. Take care and God bless everybody.
Thank you, Jerry.